Good evening, Mandar sir.
Good evening, ma'am. Yes, sir.
Sir, we will wait for 2 3 minutes.
Yeah, sure, sure, ma'am. No issues. Yes.
Sir, shall we start?
Yes, yes, you can. Yeah.
Poonam ma'am, you can start.
Am I audible, ma'am?
Yes, yes, yes.
Yes.
A very warm and pleasant evening to one and all present here. I, Miss Poonam Potraje, on behalf of Information Technology Department at AC Patil College of Engineering, Kharghar, welcome you to the fifth session of 6 days online ATAL FDP, that is real world applications of HPC in industries, case studies. Without further delay, it is my honor to introduce today's esteemed speaker, Mr. Mandar Gurav sir, a distinguished HPC performer, specialist at CDAC Pune, currently pursuing his PhD from IIT Bombay. Mr. Gurav has dedicated his career to advancing high performance computing technologies. His research interest includes parallelization of scientific codes, heterogeneous high-performance computing, performance analysis of program, and optimization techniques. These focus areas have positioned him as a leader in the HPC domain. Mr. Gurav has an impressive portfolio of completed projects include porting and optimization of CFD code on GPU phase 1 and phase 2, the CODA implementation for scan matching algorithm, and the parallelization of circular simulator, among many others. He has also been an outstanding educator, conducting numerous training programs on parallel programming using CUDA, OpenMP, and MPF, featuring hands-on session at the prestigious institutions such as IIT Madras, IIT Bombay, IIT Guwahati, IIT Manipur, and across the India. Additionally, he has delivered a guest lecture on HPC application development and tools, and the institutions like CMMACS Bangalore. Mr. Gurav expertise extends to mentoring. He has served as a mentor during the Open ACC hackathons at IISER Pune, IIT Bombay, and CDAC, guiding participants in advancing their HPC projects. His exceptional performance earned him the prestigious title of Best Outgoing Student of Walchand College of Engineering, Sangli, during graduation with the gold medal and the crash prize, recognizing his outstanding academic and extracurricular contributions. We welcome you, sir.
Thank you.
Please accept our virtual token of respect.
Yes,
Now,
thank you. Thank you.
I request Mr. Mandar to start the session. Over to you, sir.
Yes, thank you. Yeah. So let me share my screen. Ma'am, can you see my screen now?
Yes,
Yes.
sir.
Okay, okay. Thank you. Good evening, everyone. So I think Monday I was there for one of the session. Okay, so probably you have seen some of my slides. Okay, so what I'm going to talk about today is mainly what are the different areas where people use HPC. Certainly, the list is very comprehensive, so I'm not going to cover each and every area. But I thought probably some of the interesting topics I can just quickly talk about, and if there are some questions, I can take it up. So I will talk about one or two projects which I worked on, but mostly it will be general ideas from diverse field. Okay. So why we want to do HPC? So I think some of the faculty members might have already talked about this part. So my focus today is like, how do we apply HPC for a lot of different industry challenges, right? So what we want to do is like to take a given problem which resides in a physical world, try to somehow like apply some mathematical model to that particular problem. And once I have a mathematical model, I can like then discretize that particular problem and solve it on a computer. Okay, so that's how we can solve a given particular problem. There are like a vast number of industries where people have been using it, and like the very first point which I mentioned is weather forecasting, which has been like the key driver of HPC since the very beginning. Okay, so that's why like talking about the application without weather forecasting is kind of like mandatory. So we'll briefly touch upon what are the challenges with weather forecasting, and probably like most of you might have realized this part when you actually go and look at the weather on your app, or like from IMD or through newspapers or whatever. And probably it might say, or you might get an SMS where it says like red alert warning or whatever, it might rain or whatever. And certain days like it doesn't even rain, so it will be like proper sunlight, and there are no cloud cover available and so on. So why those things happen, like we'll briefly touch upon that part, because I think like most of the people might be like sincerely like cursing a lot of these like government departments, saying that hey, like these guys give like not so accurate predictions. Okay, so that's one part we'll briefly talk about. Then another like very broad topic, which is computational fluid dynamics. So I have like number of examples which certainly will relate to you in some sense, so that's why I like put. Then obviously a lot of the examples from like medical imaging and diagnosis, but I didn't like cover those things in detail. But I think many of you, or your like family members already must have done some CT or MRI scans, right? So when you go to such large, or even like um, simple scans, like such as like 2D echo and stuff like that. So there also they have a dedicated, I wouldn't say HPC server, but dedicated workstation attached to the device. So for example, if you see the CT scan and MRI machines, they will have their own workstation supplied by the same company who is supplying your MRI machine or CT machine, which has a very like powerful processor, as well as like powerful GPUs, so that they can actually take those slices of the scans and build it into a 3D reconstruction image. And then the actual doctor will look at the scans, and then he will diagnose like what's wrong with your organs and so on. Then another very big like topic is bioinformatics, which I think like probably everybody is aware of. Okay, so now there are like so many sub application domains within bioinformatics. Well, in general, you must have heard about this human genome project and so on. And people say that future is like personalized medicine and so on. So whereas like currently today, if I go to a doctor, doctor will look at like symptoms, and will say like general prescription he'll provide for whatever like problem which I have. Whereas in future, like doctor will have access to my like genome sequence or DNA sequence and so on, based on my particular like DNA or genome sequence. He might like specifically give me a certain type of drug, which probably for the similar kind of problem other patient may not get, right? So there also you need a lot of computational power, mainly because all these like sequences that we scan out of the this DNA are short scans. And many of you might have heard about this, like you have to combine all these short scans to build a full DNA and so on, right? So that's also another challenging problem, where like a lot of computational power is being used. Then probably like everybody is aware about financial and economic model. So what people do is like they want to forecast, right? So a lot of the times you hear these like news, right? So India GDP growth will be so and so. Those are all like forecast or predictions. Okay, and like sometime in future, when like all the data is available, government will come and say like okay, so for last 6 months or 1 year, our GDP growth rate was so and so, whatever, right? So like that, there are so many different forecasts and modeling has been done across different industries, so that they can make their business decision more accurately. Okay, because the economy, if it is going to grow, then certainly they will plan certain things. If they feel economy is going to kind of stagnate, then they are going to plan something else. And if they feel okay, probably 1 or 2 years might be some kind of a slowdown, then probably they will plan something else. So these kind of financial modeling, most of the industries where they are some or the other way connected to the economic factors, they will always do, okay, on their own. And there will be some companies will offer these services. Another thing, many of you, and in fact our audience is computer science faculties mostly, so I believe many of you might be already doing some kind of trading on futures and options and whatnot, right? So there also some of my friends also do it, you can do automated trading where you can take the APIs which are provided by Zerodha and other companies, and you can actually pull out the data, model the data, and you can make those buy and sell calls and those kind of things. Okay, and in fact in US, if you see, there is this very large or very sophisticated thing called as high frequency trading. So large companies have huge computers do this model and buy and sell at really large quantities at fraction of milliseconds by earning millions of dollars per day, right? So that's also something that it's very much matured across the west, but probably in India, still we are kind of evolving. Then certainly, advanced graphics, virtual reality, and entertainment industry. So you see a lot of these animated movies, a lot of computer graphics being used in action movies, which require really large computational power. So typically, they call them as the render farms. So you have a large, not necessarily HPC machine, but HPC kind of machine, which is specifically built for this kind of application, which will be actually used for rendering the 3D scenes and so on. So that's how your movies are kind of built, right? In fact, in India, I think 2008 or 2010, sometime around that time frame, probably, Tata's built one of the largest supercomputer in the country. So it was fourth largest in the world and fastest supercomputer in Asia, and fastest supercomputer available on commercial basis. Okay, so it was essentially used for visualizing or rendering a lot of the movies at that particular time. Then a lot of the F1 Formula One racing companies used to stream live data from the actual race. They collect some of the sensor data, feedback to the supercomputer. It will simulate and feedback some of these things so that they can improve and so on. So those kind of also applications which people use in entertainment industry, right? So and as I said, list is extremely large. So if you go to Nvidia's website or any other HPC vendor's website, you will see that there are hundreds of different types of application from across all the domains. People are used HPC and people are using it significantly for a lot of their scientific advancements. And towards the end, if you get some time, probably I'll share more details about why a lot of these countries spend a lot of the time and money building such machines, because it makes sense financially for them, even though a lot of these machines are super expensive. Okay, so we'll come back to that part if we have some time towards the end. Okay. Okay, so let's start with weather forecasting. As I mentioned, that is one of the very important and critical application since the beginning of HPC era. Or I would rather say, these are this is some of the application which actually enable people to go and think about HPC kind of infrastructure. Because here, if you can see, when we actually do the weather forecasting, it's very complex problem, computational very intensive problem. So I have just given a simple cartoon here, which actually looks at the atmospheric model. Okay, so what is atmospheric model? Atmospheric model is a simulation tool which simulates the Earth's atmosphere, and based on that simulation, you can predict what kind of rain and wind and all the cyclones and those things, right? But the point is, atmosphere is not only one factor. Okay, there are a lot of other factors. So another factor which is also visible here is are our oceans, right? So until and unless we model the oceans, and then you couple the atmosphere and ocean, because all the ocean surface temperature is directly facing to the atmosphere, and all the atmospheres temperature rise and everything is going to affect the oceans also. So it's a connected system, right? So there are different factor which actually consist in a full scale model. One is atmosphere model, then there are these ocean models, then there are these land and sea ice models. Okay, so once you combine all these models and you couple them, so that every time step they talk to each other, okay, and sync up their data, so that whatever things that you have modified at the atmosphere level, those things can be exchanged with the ocean layer. Okay, whatever is happening at the ocean layer, ocean can transfer those things at the atmosphere, because ultimately we are trying to solve some mathematical calculations, right? And all these exchanging of information will make these things more accurate. Okay, but now generally people say that those predictions are not accurate and so on. So I just want to spend a couple of minutes, because people see it as a classic computational problem, which is not. Okay, it's a computational problem certainly, and there are a lot of models available, and each one has its strengths and weaknesses. But at the same time, when we are in country like India, we have to always think about, okay, so what is there and what is not there. Okay, so from computational perspective, okay, so we have a certain computational power, but as compared to other global players, okay, that computational power is not that significant. Okay, that's point number one. Point number two, our models may not be as great as available in West. Okay, and there are good projects happening here in Pune and across the country, which are called as monsoon missions, where they are trying to improve the accuracy of the model which we use. And currently we are in monsoon mission 2, if I'm not wrong. Okay, if you are interested, you can go and visit this website called as Indian Institute of Tropical Meteorology. So these people are responsible for building all these models and so on, right? And most important point, even though you have the world's fastest supercomputer available, even if you have a great model available which has a really high accuracy, until unless you have a data which is very accurate and very refined, okay, your model will not run correctly. So for example, if you look at West, they will have large number of weather stations collecting a lot of the data. Whereas in India, we don't have that kind of data collection happening. Okay, so for example, if you have heard recent news that government is setting up a large number of Doppler radars across the country, so that you'll have lot of real-time data coming in, which will be fed to these models, and then the accuracy of these models will improve, right? So again, this is land-based data collection. At the same time, there are these satellite-based data collection which actually look at what's happening on the ground, and it can collect a lot of the information such as temperature and humidity and whatnot, right? So if you want to get the most accurate predictions, okay, you need to solve this very refined problem. Okay, at the same time you need to have this large amount of data available, okay, collected on the ground as well as at the top of the atmosphere and so on, right? So when you combine all those things, you get the most accurate results. Okay. So from computational point of view, if you see, I've shown this diagram where you can see there are these 3D blocks, right? So this atmosphere is divided into small blocks. Okay. So when we look at the atmosphere, there are three dimensions: X, Y, and Z. Okay. So X and Y is my surface. okay, and Z is like vertical atmospheric height. So the problem with this thing is like if you look at the x and y dimensions, those are like thousands of kilometers. Whereas if you look at the z dimension, it's like just few kilometers. Okay. So the point is we call it as a shallow water equation problem, right? So here the x and y are very diverse, okay, very large, and you